Okay, in this video we're going to cover logical routing in the Ciw Python package. Calling it logic or logical routing seems kind of weird to me because it's all logic in the computer, but nonetheless this is one of the named types of features, and it's definitely worth knowing for customizing how customers or whatever flows through your network will flow through your network. So let's get started by first importing the Ciw Python package, of course. And now we'll jump into the new part right away. We'll define a network shortly, but let's define a new class, custom routing. And we're going to subclass from a class that is intended to be by the developer of the Ciw Python package to be subclassed. So that's the node routing class that you can find in Ciw.routing. And there's a specific method that you should subclass from. That is the next node method. You should override it, and it needs to take, of course, self, because it's going to be something that's run by a class instance and requires self data. And also the individual. So we'll put a type annotation here of Ciw.individual. And I guess technically we should probably put that its return type is what, like a Ciw.node type, I suppose. Is that right? That might be right. We'll continue. Okay, so let's make a custom routing behavior where at the node that has this routing behavior, that maybe it's time dependent. So we'll go self.node.now and say that when that is greater than or equal to 50, that we will return self.simulation, and we will access the nodes of the simulation, and we will take element 4. Function declared with return type. Maybe I'm wrong about the none is not assignable. Oh, it's just saying that, yeah, we haven't defined all possible return paths yet. That's to be expected at this point. Okay, so we return self.simulation.nodes 4. That is when it's sufficiently late in the simulation, when time is greater than or equal to 50, that whatever node has this custom routing will send the customer to node 4. Now let's continue with maybe some more cases. We'll go maybe simulation. That when self.simulation, that is accessing the simulation object, and we'll grab node 2 out of the nodes, and that if the number of individuals, so here we're grabbing something that's kind of more so-called state dependent rather than time dependent, whereas the last condition was definitely a time dependent thing. Here we'll go return self.simulation nodes, and we'll say node 2 is returned. Now we'll cover one final branch to cover it. You need to make sure that for this return type that it always returns a node. So we'll go self.simulation. And so if it's not one of the other nodes, it will be node 3. Okay, so we didn't actually use the individual in this case, but that's also a kind of data that you could use. That's fine. We don't have to use it. So let's define a network as we always do with Ciw. Let's create the network using this constructing method or function. So arrival distributions in the documentation example that we're following here. Let's say that it has a Ciw.dist exponential with a rate of 1. And we'll just say for the rest that there are no more arrivals at the other 3 nodes. Okay. Next, we'll do service distributions. And we'll say Ciw.dists, and here we're going to do deterministic. We could, of course, use other distributions. There's nothing that's particularly special about these choices. You can mix and match the components in Ciw as you like, so we're just going to throw the same one at all of them, but again, that doesn't have to be so. And we'll set the number of servers to be 3 at the first node, and then 1, 1, 1 for the other 3 nodes, okay? Now, let's see. We now can define the routing behavior, which is, of course, what we're here for in this video. Routing equals, and we'll go Ciw.routing, and we're going to define one of these network routing instances here. And inside of that, we'll define our routers. It's a list. So we'll actually, for node number 1, throw in this custom routing class that we made ourselves. And then we can also mix and match. So here we're really just gonna do leave the network entirely. And really, these leave routing objects are fundamentally from the same class inheritance as the custom routing that we've got here. Naturally, wouldn't want to call this custom routing for your own project. That's kind of a weird name to give things, but hopefully it helps emphasize that that's a thing that is not a built-in part of Ciw. That's whatever you decided to add. Okie dokie. So let's set up a simulation, Ciw.seed, and we'll set it to 0, and we'll say simulation is bound to the value of simulation with our network being the thing we pass into the simulation object. And then we'll take our simulation and we will simulate until, oops. We'll simulate until maximum time of 100. And then we'll get our records. These are where the customers or patients or whatever they are. Oops, not all individuals, but all records. We've covered in past videos about the different types of records by and large. And maybe we'll check some conditions just to, make some assertions about, we say that certain things are true in this routing behavior, like that if the time was greater than 50 when we were deciding the routing time, it should go to node 4. Well, we might say that's condition 1 is all, and we might say record dot service start date for that customer being greater than or equal to 50 for record. Maybe I'll even throw this onto another line. In records, if record dot node is equal to 4. That's our first condition that we ourselves kind of put into this. Now, the other one was under a supposition that the time was actually less than 50. That's kind of going down the other branch of execution. We'll call that maybe condition 2, and we'll bind that to the value of all, and we'll pull out that condition that we want. So record dot service start date is less than or equal to 50. Maybe I'll wrap that around too. For record in records, if record dot node is in the collection of either nodes 2 and 3, at least for their indices there, that's condition 2. Now, actually, I'm thinking about this. The documentation says this is greater than or equal to. It makes sense to then check just the strictly less than, I believe. All right. And then there's a third condition we can check, which we might grab all. And this is just to check what the leftovers were that didn't meet the 2 other criterion. So we've got record dot service start date is equal to 0 for record in records if record dot node equals 2. Do I have that right? Record dot, no, that's not right. I want queue size at arrival is equal to 0. Okay, so if they arrive and there's no one else there, for each of these records, and checking that they're all 2, just to double check in terms of our routing behavior, that that's really what this condition is about. So let's then print our conditions 1 and condition 2 and condition 3. And let's just take a look at this in the terminal. We'll print the result of doing this little example. Custom logic-based routing, and all of those conditions are true. So hopefully that gives you some assurance that Ciw is doing what you think it's doing when you say, what is the next node? Maybe I should have explained that more at the very beginning, but next node is the method that really decides where the individual in question being the one that's passed into this method, which we didn't use in this example, but we could bring it into some of the logic. That, look, if the time is greater than or equal to 50, send them to node number 4. If the number of individuals at node 2 is exactly equal to 0, then send them to node 2. Otherwise, send them to node 3. That's it. So you get a lot of control this way, and you can even start to have, your custom router have attributes and stuff so that it has some kind of memory of what's happened in the past. That might be more efficient than trying to grab the records during the run of the simulation. So I think that this is actually one of the more important of the routing functionalities that are available in Ciw, while is to basically be able to go, well, all that other stuff is good, but maybe I need something that's custom to the particular system that I'm studying. That can happen a lot. It's very hard to guess all possible features ahead of time. So with that, I wish you luck with your next discrete event simulation using the Ciw Python package, and have a great day.